Yeah, let's go ahead and kick it off and get started. So I will do a little bit of an introduction first, but I'm gonna let Remy introduce herself and pass it off to her, and then I can do a quick intro after that.
Yeah, hi, my name is Remy Welch. I am a customer engineer at Google Cloud who specializes in machine learning and geospatial. And I've been working with CARTO, building solutions and doing various customer implementations for a bit over a year now.
Cool. And my name is Matt. I head up our product marketing efforts here at CARTO. Been doing geospatial my whole career. So that's always an area of interest for me. And yeah, excited to talk about retail, which is definitely interesting in the geospatial space, as stores are very linked to geography, as we'll find out as we talk about that today. So in the next 45 minutes, you will have learned the following items. So how retailers are using geospatial analytics with real world use cases and examples, how you can use CARTO and BigQuery to actually gain some of that insight, use your data to actually understand that retail landscape a little bit better, and then best practices for building a geospatial analytics solution, which will come along with a live demo for myself. So that we'll jump into and go from there. So just a quick, kind of understanding of where retail stands in 2023. Of course, as things are changing, there's inflation, there's price increases and things like that. And that's pretty common across the globe, actually. Some areas more than others, but as you can see here, lots of different countries are seeing anywhere from like a 7-10% increase up to the mid-teens, and then some countries have pretty extreme increases depending on where you are. So that's definitely a global concern as people are looking to understand what those changes are and how that impacts the retail landscape. So that's something that we can kind of keep in mind and understand how that may have shifted purchasing patterns in retail as that has changed. The other piece is, how spend has shifted, and where is that shifting in terms of the, sort of recession that we sort of find ourselves in today. Of course, I'm not an economist, but that's sort of the trend of what's out there. But you can certainly see that there's different areas where people are spending less, spending more, and then spending the same as before. So we'll kind of take a look at the spending less side, which is eating, entertainment, food delivery, and then from a retail side, what's interesting there is clothing and apparel or home improvement and decor. Of course, eating, entertainment, that all kind of relates to if you have a QSR, a restaurant, or you're in the food area. That's one that's interesting. Where they're spending more is on, of course, if you're not eating out, you're eating at home, where you can see that is reflected over here, where you have that increase in grocery items, and then of course utilities and transportation, education. So you can see the two sides of that. What is that looking like? So there's two questions there. If you're in the grocery space, how do you understand what that increase means and where those customers are coming from? And on the other side, how can you still capture customers in wallet, given that people are spending less in these different spaces right now? So how can geospatial analysis help? And I think there's a few different areas here we can kind of cover and talk about. First is around site selection, right? Where are the best locations, for expanding and consolidation, right? So site selection is not simply, I want a new location, but it includes that is one question, of course, you can answer, but how are my locations performing? What's the spatial context in which they're performing? Where might I want to grow my presence, or where might I want to decrease my presence? And how do you make those holistic decisions looking at your entire sort of network of locations? Which leads into portfolio analysis. You want to understand where things are performing well or maybe underperforming, and then understanding your customers. Where are they? Who are they? And how are they interacting with your footprint is some of the key pieces there. Some other ones that play into this as well around geo-marketing. How can I prioritize my market investments? If you're going to invest in marketing, where do you want to do that? Where does that overlap with your footprint and, once again, your customer segmentation? How can you optimize your supply chain for optimal delivery and those other pieces that feed into that? And of course, logistics is how can you make your deliveries be more sustainable. So if you have these other elements that are coming into your retail footprint, certainly these are geospatial pieces you can layer on. All of them, definitely play off of these first few pieces where you have your understanding your network and what to do with that, where does it exist and how is it working and where are your customers. And then you can layer all these other decisions on top of that to help you do things better, from logistics to delivery from your retail locations, or sort of micro delivery hubs, supply chain, and then geomarketing decisions. So how are retailers using geospatial analytics? And I think, Remy, I'm passing some of this off to you, correct?
Yeah, for sure. For the use cases slides.
Okay.
Okay, awesome. Yeah, it's just taking a second to update. There we go.
There we go.
Yeah, so talking specifics, which is always my favorite thing to do. The first case is the Coca-Cola Bottlers of Japan Incorporated, which is very hard to say, so I'm just going to call them CCBJ. So you may be aware of this, but Japan is obsessed with vending machines. It may seem kind of odd to Westerners, but in Japan, it's not uncommon to see a vending machine right outside of someone's home or by a school or in an alleyway. It's actually very convenient. So CCBJ manages over 700,000 vending machines across Japan, and they collect a lot of information about how each individual product sells in each individual machine, which of course is a lot of data. Historically, CCBJ would have to extract that vending sales information and manually tie it to more general sales, as well as sociodemographic information. And of course, there's a geospatial component to all this data, because the location of the vending machine is very important. And anyone who works with geospatial data knows that bringing it in can really complicate an analysis. So the first thing that CCBJ did was bring all of that data into BigQuery under one data warehouse in Google Cloud. And I'll talk a bit more about BigQuery in a couple minutes, but it's a cloud data warehouse. So they got that data in BigQuery. They then enhanced the sales data with foot traffic and points of interest data from CARTO's data observatory, which was easily brought into BigQuery with just the click of a button. All of that data amounted to over 2 billion rows. So to help visualize it in CARTO, they processed the data into tiles using the BigQuery tiler tool, which is cool because with a few clicks of a button, or you can use it programmatically if you want, but you can customize how the data is aggregated into tiles, and how it's shown on the map as you zoom in and out. And you can choose the attribute order in the tiles. So if you have attributes like revenue that are more commonly used and visualized, BigQuery will actually store the data in an optimized way, cluster it, so that you can quickly return those attributes. So all that analysis is great, but of course, what about machine learning? CCBJ used all that same data in BigQuery to build a model in Google's Vertex AI platform, which predicted the potential sales of vending machines in new and existing locations. So on the right hand of the slide here, you can see the heat map, which shows not only the predicted sales of existing vending machines, which of course allows CCBJ to more accurately restock their current machines, but it also predicted if a vending machine were to be put in that location, what the potential sales would be. So excellent for new vending machine locations. So a great use of both Google Cloud and CARTO. You can jump to the next one, Matt. Allegro. So Allegro is the most popular shopping platform in Poland, and the largest e-commerce platform of European origin. In Allegro's case, they wanted to speed up deliveries and optimized where they placed their parcel lockers for deliveries. And after assessing a number of options, Allegro chose BigQuery and CARTO for building their more modernized data platform. Like CCBJ, they leveraged data sets from CARTO's data observatory to enhance their existing data in BigQuery, and using the CARTO builder, which enabled you to quickly prototype applications and then further build on them. Allegro built a site selection application. And it was really CARTO's ability to integrate seamlessly, not just with BigQuery, but with all the other tools in their diverse tech stack that sold them. So now we get to my favorite part of any presentation, which is a live demo, and I'm going to hand it back to Matt for that.
Yeah, so I will jump in, and what we'll do is walk through two different pieces here. The first is actually a blog post that we put together and worked on for some time that walks through step by step what's happening and kind of all the pieces, all the steps that we're taking from a retail analytics perspective. And there's different things that are happening there, but we want to make sure that that's fully accessible. And we just exit out of here and get everything pulled up, and you can kind of understand the pieces that you want. So we'll drop this in as a link so you guys can all reference this and come back to it. But effectively, the CARTO as a platform has a few different pieces, right? If we're looking at this architecture diagram, which I'll zoom in on here, and hopefully everyone can see it, is that what we bring in is that, there's input data on your left-hand side right over here. And then there's the retail analytics that are the outputs. In the middle is where kind of all the magic happens, right? But these are all the data sets that you can bring in. And minimally what you want to have are, of course, where your locations are. And that includes revenue or some metric of performance at that location. Right? If that's number of visits or items sold or whatever, however you measure a success ratio, right? In most cases, that's, dollars or units sold or something like that. That includes other pieces that you can have in is where your competitor is located, data about your customers. That could be anything from simple demographics all the way up to more advanced metrics like, customer segmentation or, loyalty programs or anything like that you can tie back to a store location. Another one that I think is really very interesting, especially when we talk about this in the context of BigQuery and a data warehouse, is point of sale data. Of course, you're collecting lots of different, information about what is being sold, and even down to maybe the item that is sold and how much, if there's a discount tied to it. All those data sets can be tied back to a location, and you can really understand at a very granular level maybe how those interplay and perform. There's specific products that do well in certain areas or things like that. That certainly helps. And then there's other data that you can bring in, which is from our data observatory. CARTO has open and public data that you can use. That's basically free with the platform, as well as data that you can acquire if you so choose to pay for that. And we'll show a demo using the open data, which we have as a part of Google BigQuery, and they have done a great job of bringing OpenStreetMap data into BigQuery as a public data set, and then open data from CARTO, which is our ACS demographics. Once that comes in, there's basically a few different pieces that we're using. Today, we're going to cover these four right here. So if you can see as I'm moving the mouse around, maybe I have a little. I think I can do a little like this. Okay, well, it didn't work. I was hoping to use the little highlight feature. I never used it before, but apparently didn't work. So CARTO Builder is the first one. That's where we're going to visualize everything and see the end outputs, right? So that's where the map will be. We'll have the data observatory, which will enrich with our spatial data, our analytics toolbox, which runs a set of 3 retail functions. We'll talk about all of them in detail. And then CARTO workflows, which is how we put this into sort of a no code, visual workflow interface. And it's very easy to work those steps through and kind of understand what's happening. All of that is powered, of course, by BigQuery and Google Cloud. So everything is running there. No data leaves BigQuery. We don't do anything else to that. It just lives natively there. And if you've ever dealt with security or things like that, that certainly is a challenge. There's other parts to the platform, and we can take a quick look at that, which is the site selection application, which is a purpose-built tool that is basically a front end that sits on top of these same analyses. They're nothing different, but they sit there as well. So we can take a brief look at that too. And then what do you get out of that, right? Is of course all those use cases that we talked about. So zooming back out, you can read through the data sets that were used and then some of the analytics that you're able to perform. So what the two that we're going to look at today are white space analysis. So, identifying the best possible locations. Where are there great locations to sort of potentially expand to, and how, where might we see increased revenue? That's one that we want to do. The one that we went through in this tutorial is twin area analysis, and these are using machine learning driven analytics. And I know that gets very general when we say like machine learning. We'll talk a little bit more about like what models we're using, because they're all things that if you have a data science practice or are familiar with machine learning, these are models that anyone can run, but BigQuery basically makes them very easy to use and scalable within their environment. There's also revenue prediction, so you can predict revenue across store locations of your existing ones or new store locations. And maybe that's benchmarking, and then cannibalization. How do you understand these overlaps? So all these are modules within the CARTO analytics toolbox for retail. So if you click over here, we should be able to see these actual descriptions. Now, if you're not familiar with SQL or queries, right, this may look a little bit foreign. We'll walk through each of these in detail. If you are familiar, effectively these are stored procedures where we group a lot of different queries together and run them all within within Google BigQuery. So there's all of these pieces that you can use and query and run time over time to actually do that and run. So we'll go into those in more detail later, but here's an actual example of what we did. So the first step is to build your model, your revenue model, right? Which is understanding how, there's revenue. So the first piece is you have a table of, that has your revenue, your stores, or, your store ID and a geometry, right? So that's the first step. If you have information variables, this is optional, but this could be like square footage or, does this location have a Starbucks inside it? Anything like that, you could kind of include as extra data, right, that you want to have. They have your competitors data. So, you have different competitors that you might have, an area of interest that you want to focus in on. So you could select, maybe I'm just curious today about Texas and Arizona. So it's very flexible. I could go the whole US, I could go a metro area. It doesn't matter, right? You can get very level. And then we use a gridding system here. It's the H3 spatial index system to keep that in mind. There's very easy to understand, and it provides a very scalable analytical model. So we can talk a little bit more about what that is. There's a white paper on our website if you want to learn more about spatial indices, but they just make everything faster and more predictable compared to using a boundary like block groups, which are a little bit strange as you move around the country. And this is where the data enrichment happens, right? So this is all different variables that we've pulled from our data observatory. If we want to go back here and look at the data observatory, oops. So this is the CARTO workspace. You can actually search data through here. And these are variables that we chose to use. So this is total population, age, households, population over 25, median income, income over 200,000, median rent, employment data. So these are just some open variables that we selected as open data from the spatial data observatory here. So if you go into demographics, you'll see we have lots of data from the American Community Survey, and we're just using public data. So if you sign up for a trial, you can do all of these same things and work through that. And then we have our American Community Survey here data. And then let's say we wanted to use our demographics. We have all the different vintages. So if you want to go back a little bit further, but sociodemographics, census block group 2019, you can see all the data here. I've subscribed to this data set. If you haven't, you just can subscribe to it. And then you can go over here to actually see what's in the data. And then each of the data sets have some very specific pieces. You have a data set ID here, as well as a different data set, what we call a individual sort of identifier. So we see this total population metric here that basically translates to what is right here. And that is specific to that data set in that spatial resolution in that year. So it's unique to that, and you can use those to enrich your data. The next piece is that we're using to build is building our revenue model. And this model, it supports two different operations. There's a lot of different pieces you can include in here, but it supports the linear regression and then boosted tree regressors as well. So those are two different models. If you're familiar with machine learning, those should sound familiar, but you can check out the model documentation from Google Cloud as to what those are and which one might make the most sense for you. So you basically build your model, you pass in that data model that you built already, and you give it an output. And then you have some options here. And this will return the model and then some model statistics, that is how well is our model doing, and then the SHAP value for what that predicts to. And then finally, we actually predict our twin areas here. So this is what we did with the twin areas. We can call this function to predict those and actually see the interactive map here. So in this case, we're looking at areas in Texas. These are our store locations in Austin. Austin, for this theoretical store, had very high performers just based on the fact that there's population booming. But we can open this up and actually see, okay, how similar are locations in Dallas to those really high performing locations in Austin. So that's what we're trying to compare here. And we can actually look at this and say, how similar are these different areas? So we can see that these are the best performers. And then we have our similarity score. Basically, the higher the score, the more similar they are. And we can see here that these are the most similar areas and ones we might want to potentially replicate as a new location, right? So that's basically what this module does, is it gives us the best fit location. So if I want to just pick the best of the best, we can see what those look like in the Dallas-Fort Worth Metroplex. Moving down here into Houston, what did those look like? And you can kind of start to see some different things pop out. You're looking at, areas around other retailers near a highway, just visually, this is some of the things that initially stand out to me as I start to move around here. So that's something to kind of keep in mind is, what they would map to in a similar locations. So that is our first part of the demo. You can actually take this for a spin. There's a free CARTO trial that you can start out with. But as promised, we want to give a much live version of this and kind of show what that looks like, especially if you haven't worked with SQL before. What we're opening now is our new workflows tool here. So this is the same structure, but what's going to get outputted here, what our output will be is effectively a white space map. So we want to say for our locations in a specific area, I could pick any area to study. Where are there other best fit locations, or where are there areas that I don't have a location that would be potentially a high performing location based on revenue? So that's what we're doing. We have our data loaded up here. We're just picking the theoretical store that we're studying is target. And we've effectively tried to model some fake revenue data. So this has nothing to do with them as a real company. It's just sort of based off of some very simple metrics. So we kind of model what that looks like. And then the first piece is doing some simple data prep here. So we build all these modules into SQL, so we have a little bit more control over them, but we can basically select our store, sales, revenue, and just filtering to the data that we need. That provides a named input here that goes into our revenue model. So the same things we were putting in before. These two steps right here, which is the building the model and the model data, are going to be the same for each. We're going to filter down to the state of Wisconsin and enrich with the same data as we had before. And then we call this procedure here, which is going to be basically building that new output. So this can go ahead and run. It takes about 7-8 minutes to run and recreate the model. But in effect, you could actually do these two steps and then call these different procedures over here as many times as you want. So you could theoretically split this into two workflows. Once these two things are set, you're kind of done and ready to go. What we want to get out of this is finding white space. So in that same state of Wisconsin, are there other areas based on what we have that would be good to potentially expand into? And that's what this model here is going to do. So it allows us to do these same steps. Now, what's great about workflows is you can do a pretty massive amount of data prep here if you wanted to do more modeling or things like that. So if you wanted to, maybe this is an example of incorporating weather data. This is with Kroger locations, and you wanted to, add weather data or patterns. You can do all of this same data prep and save that out as a table. and then go back to your original workflow here and save this and start running from that data set. So it allows you to orchestrate this visually, and then actually build the models here that you can run as many times as you want. So with that, we have our final table that we have as an output. And this is what our white space model looks like in Wisconsin. So what we wanted to do was around some, a few key metros, really study and understand where there's higher or lower revenue based off of the data that is specific to that state, right? We're keeping this very specific to Wisconsin, and you can start to see we're basically focusing on Madison, Milwaukee, and down here we have the Janesville sort of metro areas. These are the areas where we have sort of some existing footprint and we want to potentially expand. So what this did is in each of these cells, it predicted and created a new theoretical store and tried to predict revenue for those areas, right? And said how much money would a theoretical store in that area make. What's great about this is I can quickly add a widget here. And I can pull that to our revenue average and then start to, pick the high performance. We'll drop this down to like 6 buckets. So it's a little easier to filter. And we can easily see, okay, where might we want to start to expand? And we get some clear patterns here. If I go to the style, we can see some, let's go to add some transparency to this so we can see through a little bit. Here we go. And we start to see some other patterns pop up. So it's actually down here is there's some, potentially some expansion around these smaller rural areas, which is interesting to see those pop out, but that's where they see some potential and, some of the ring suburbs around Milwaukee. As we start to add that out, you can start to see where these patterns really start to emerge. It looks similar to kind of what we saw before. We have basically, areas around high frequency of travel or roads, near maybe other shopping areas and information like that. And we can start to add and see what that looks like by adding a Google map here. So we do have other, shopping, intersections, that type of thing. And then that all adds in that other data from the census information that kind of correlates there. So this seems about right, and it gives you an actually what's I think my favorite part about this is since it models a store, I can add a simple hover window here. And what I'll do is just add in our average revenue predicted here. So you can kind of get a sense of this is daily revenue, what each of these vary by. So you can get a good sense of, even on this granular of a level, what that might be. So you can kind of start to say, okay, where might I want to focus in on either after going to this such low of a level. Now, what's interesting about this is you can run this as many times as you want. Of course, this is, pretty high level. All of this can, of course, be accessed through our site selection application. So if you sign up for CARTO, you can actually get access to this demo instance of this application. This runs all the same models. So without getting too deep into the science of everything here, you can actually access this and explore this application, which does the exact same thing, but just through a pure user interface. So what you can do here is here's our existing locations. Go to keep our geography consistent here. If you want to explore Milwaukee or Madison, you can see what that is. You have your different layers here as competitors you can turn on and off. You can look at some of the dominant, geosocial segments and things like that, and start to analyze. You have your white space national twin areas. These are preset, different analyses that you have access to. But if you want to run one on your own, let's say we have our white space analysis. This might be a good location for expansion. You can see the predicted revenue here. Go ahead and simulate a location. You can drop a pin, simulate that, enter your parameters, and this runs all those same models still in BigQuery, still connected to everything that you have, and gives you some extra parameters you can play around with here. Does this have parking? Yes or no? What type of store is this? Is it near a traffic light? So you can, play with all these pieces and then actually see the outputs of those here. So I haven't run any here in this demo version yet, but feel free to play around with this and check this out. Because once again, going to the very base level of what we're doing, here with this code and everything we have here, if you're a data engineer or data scientist and have some skills in the programming side, you can certainly use this and do it as much as you want and get that fine control. Or if you want to expose this to a business facing unit and have some more visual, interactivity, that's certainly something that you can do there too. So those are all the different pieces of the kind of complete retail structure. I'm going to jump back to the slides here. If you have questions about what we just showed, please drop them in the Q&A, and we'll certainly kind of address those as we get going. But yeah, that was the demo for today. So Remy, I'll pass it back to you to talk a little bit more about BigQuery.
Yeah, sure. So yeah, BigQuery it has been the backend for everything that Matt just showed in the live demo, as well as the use cases that I talked about earlier. And when I say backend, I mean it is where all of the data has been stored, in addition to the actual compute engine where the queries and calculations have been executed. So for those not familiar with BigQuery, it is a petabyte scale cloud data warehouse that's part of the Google Cloud platform. At its simplest, BigQuery is like a console where you can browse your data that is stored there and submit SQL queries. But that's really just like a small portion of what BigQuery is. You can connect BigQuery to other databases like Cloud SQL or even S3 and do federated queries. You can read and write data to BigQuery in BigQuery from external applications using the BigQuery APIs. You can schedule automated queries or data loads with just the click of a button. And you can even do machine learning in BigQuery using the BigQuery compute engine, as Matt just showed. So even if you do know what BigQuery is, you may not be aware that BigQuery also has the most robust geospatial capabilities of any cloud data warehouse. Next slide, Matt. Oh yeah. So what you're seeing here is the BigQuery GeoViz, which is no replacement for CARTO, believe me. It's just a very simple tool where you can quickly visualize smaller subsets of your geospatial data in BigQuery for more like discovery type use cases. Where BigQuery really comes in is the processing and the analysis of geospatial data, and it is very fast at that. So BigQuery Geospatial has over 100 geospatial functions, all in familiar SQL, and it covers all the core GIS functions like measurements, transform, constructors, etc. BigQuery can natively ingest vector data in GeoJSON or WKT, and for other formats like shapefiles or even raster data, you can use a Google Cloud tool called GeoBeam to convert to the format you need and directly ingest it into BigQuery. Next slide, please. So when I say it's fast, it is very fast. So this is an example. They had 12 million statewide parcels over the state of Texas. The query was how many of them have impervious surfaces. So you can see there in the query editor. And this is executed directly in BigQuery, not through CARTO, just to be clear about that. Not that it makes a difference in what the actual query is executed, but so you can see it's a string intersects function, returned over 4 million polygons, and that entire query was executed in 12 seconds, as opposed to that same query taking 5 hours in Cloud SQL. And of course, if you were to try to execute that on your own computer, it probably wouldn't work at all. I guess, yeah. So we also did other benchmarking tests against other geospatial cloud data warehouses, which may or may not have been Snowflake. And on smaller scale queries, which is queries around 500 gigabytes, BigQuery was 3 times faster. on larger scale queries of 5 terabytes of geospatial data, BigQuery was between 5 times to 40 times faster. So it is very much optimized, not just for general data analysis, but also for geospatial. Okay, now you can go. So what does this mean for CARTO? Well, CARTO has all of these wonderful pre-built analytical functions and of course, beautiful visualization capabilities. It just needs the geospatial processor and a place to store the data, which is where BigQuery comes in. So here they, you can see the builder, which Matt, of course, just showed, and that query there that's in the SQL editor is what is sent to BigQuery, and you can even edit it directly in the editor there if you so choose. I have another customer, CoreLogic, that is using CARTO for this exact reason. They have their data in BigQuery, and they can do whatever analysis they need to do using BigQuery, whether it's related to geospatial data or not. And then they can easily visualize the geospatial components in CARTO without the need for any other tool. Like, for Mapbox, for example, there would have to be the movement of data out of the warehouse in order to visualize it. So yeah, they make a great team. And I think that brings us close to the end. Just Matt to kind of finish up. And yeah, thanks. Well, happy to answer questions now.
Yes, we went over this kind of diagram before. It's in the blog post, which we'll make sure to, I'll quickly drop that in the chat so everyone can have access to that. There's another guy that Remy also reminded me of that is we can share as well, so you can get a little bit more detail there, to take a look at that. Like we said, there's all of these different components, and if you want, we can talk about what's being used within each of these models. But if you go to the documentation link here, it tells you exactly what's happening and what's being done. There's no black box modeling, like we're not some magic AI, or ML that's happening where you don't know where your data is going, but you get these really awesome answers back. We want to give you the tools to do that. Our team is here to help you and guide you do that through that as well, to help you kind of build these or orchestrating workflows and things like that. But the finding white space areas and twin areas, we covered. Twin areas was the example in Texas, and white space was the example in Wisconsin. Commercial hotspots, this area locates areas where there's kind of commercial sort of viability, right? This is using a statistical method, get as GI star, that takes into factors distance from your stores, demographics, things like that. And of course, cannibalization, which is calculating trade or overlap using a custom variable, right? So you can actually calculate those. There's a few examples we have in our documentation too, so you can check those out. Like I mentioned, you can try this today. Go to carto.com and sign up for a trial, and you can actually test all of these functions out. You can take a spin through the site selection model. You'll get access to the CARTO data warehouse, which uses BigQuery on the back end and all those retail functions that I covered. So if you wanted to do that, give that a go. You can, mention that you were in the part of the webinar if you want to reach out for questions and help, and we can kind of provide that as well. But I think with that, we have time to jump into the Q&A, which I'm looking at some of the questions here, and I'll read those out before I go through, the response here. But the first one was, how do geographic tiles relate to postal codes or other standard data groups? And I believe this is in reference to the H3 methodology that we used. So I'll give my take on spatial indices. Remy, I'd like to hear yours as well, to kind of talk about those. But H3 is agnostic of sort of any sort of geometry you might think of in terms of zip codes or block groups or any of those different things, right? So that's kind of how I think of them. What's really great about them is they're similar in size and scale. They're measuring agnostic of those different boundaries, which I've written a blog post about why zip codes are not great for using for spatial analytics. But they have some built-in bias to them, no matter where they are. So this gives you everything agnostic. The enrichment engine actually enriches those. And then what's great about that is, it stores as a string, not a geometry, which cuts down on your storage. And also the processing time gets much significantly faster when you use those. And you can actually understand spatial relationships and distances and parents and children relationships and all of those. So there's advantages for all of that perspective. So it helps make those models very fast, but also very predictable from that side. Not to say that the geometry processing isn't fast in BigQuery, as we already talked about. This just adds like that extra level of horsepower and speed to make it even faster. But Remy, what are do you have anything to add from that?
Yeah, I mean, about spatial indices specifically, by default, BigQuery uses the S2 spatial indices to cluster the data in BigQuery. You can implement H3 easily if you would like to, but S2 is faster and more accurate, just maybe not as pretty as H3 in some cases. But we're talking about tiles and their relation to postal codes. It's certainly fine to visualize your data if you just have it at the postal code level. If you're, tile sets in CARTO, when you create a tile set, it will automatically kind of bin your data at zoom level. So, if you're further away and you have wider areas to visualize, like looking at an entire country, versus when you zoom in, you're looking at a specific zip code, like the CARTO tiler will kind of do that automatically as a best effort, or you can say specifically, you want this data always to be at zip code level, kind of up to you, but it's certainly, not a requirement to have more or less granular data than at the postal code level.
Yeah, it really depends on, what your retail footprint is, what matters to you. I mean, counties might be a perfect, representation, but that's where, we don't want to prescribe, hey, you must use this. You're the experts in your business, and we just going to give you tools to do that better. That's what we try to do. So, so what other types of data are most helpful to run these models? I think at a bare minimum, I think certainly having your store locations, some competitor information about it's simply enough where they are, as well as some baseline demographics. And store locations assume some sort of performance metric like revenue. I think that's baseline data, but there's lots of other stuff you can add into this. If you go into that sample application that I showed, if you sign up for a trial and access that, it's right at the top there. You can actually see some of those different data sets. But from a BigQuery perspective, Remy, I think it'd be interesting to talk about like that point of sale, or like, the actual things that get sold at these locations. Like, what I find really great about BigQuery is you can have just these massive long data sets, and then doing the aggregations or things like that are really impactful. So you might be, curious as to how a specific group of products, maybe, kids' toys or electronics are doing, or get very specific to like, AirPod sales. I don't, you could get that granular, but like how might someone do that in BigQuery in combination with the spatial piece and like the other data?
Yeah, I mean, a common use case we see is customers that have, all of their sales data, CDP data, all stored in BigQuery. And traditionally, they just run analyses without the spatial component, without the location component. Because that just makes it more complicated. But once you bring the spatial component in, like a lot of the functions are really the same. If you're comparing two groups, whether there's a spatial component or not, the way that it's, the actual SQL query itself will be very similar in BigQuery. Same for the when using the BQML and doing clustering. The geospatial data is really just a different data format. So like you might have strings, integers, you can also have geographies, and BigQuery will, has the functionality to analyze all of that.
Yeah. Yeah, I think that's one of like, especially with geo, like if sometimes it feels like you're constrained to like small data or like demographics, which isn't necessarily like massive in terms of row length, but there's always that stretch case to be like, I might have millions and millions of, or even billions of records of all this other data that I want to use. How do I do that? And this gives you like a really strong cloud GIS infrastructure to do that, but then all the benefits of ML and performance and things like that. So next question was around model accuracy. And yes, I was able to pull that up while we were discussing. So as part of the model outputs, there's two tables that get created. One is the shop model, if you're familiar with that, which basically tells you some sort of metrics about how the different factors impacted the actual model itself, and then the statistics here. So here's the model statistics. It gives you MAE, mean squared error, mean squared log error, mean absolute error R2, and explained variance. So if you look at the data set here, here's our R2 score, which was pretty good, 0.98. Mean absolute error was $168 in terms of daily sale. You can see all the different metrics here. So I think overall, the model performed pretty well. And if you want to look at the SHAP values, which I think is always interesting, certainly these are some of the the top factors here is median income, median age, and total population, right? So obviously where there's more people, that's probably a better place to put a location. What I'd want to do again after looking at that is maybe you could look at distance to a major highway or like other sort of maybe not necessarily competitors, but locations like restaurants or whatever that might be. Finding some of those pieces I think would be interesting to look at. But yeah, this all these workflows output and back into BigQuery, and like everything that's happening here is generating a pretty massive SQL file. So it runs SQL on BigQuery. That's what's happening under the hood. It just makes it easy and repeatable. And then all these things are adjustable, which is actually our next question. So within here, I can change these pieces. Workflows is a fairly new release for us. We're working on getting some of these parameters into workflows so you can have more revenue models, but this still gives you that flexibility. But if I wanted to say, change this to a different state, I could certainly do that. If I wanted to compare it, the results in Wisconsin to say, a neighboring state, Illinois or Iowa, I could do that too. So you can do that. You can add more variables. You can change the area of interest, the baseline, how much revenue is made. All these things are adjustable, and there's once these two pieces are created here, your model and your model data and your model, you can run against those as many times as you want. This is probably the most time intensive part here, and then actually running against the model is not too terribly complex. I started running one in the background. I don't know if it'll complete in time, but I switched over to Massachusetts. If it completes, I'll pull up a map really quickly and just show you what we were able to do there. So I think that answered those last two questions. Remy, once again, thank you very much for joining us today. It was great having you, and thanks for bringing a lot of your knowledge to this as well.
Definitely. Yeah. Anyone on the call who wants to reach out and talk BigQuery and Google Cloud, feel free to do so.
Yep. And yeah, same goes from the CARTO side. You can get started on a trial, or if you have questions, just reach out to us. But we'll share the recording and the slides in the next couple of days. But thanks everyone for joining us, and yeah, enjoy the rest of your week.
Thanks everyone. Thanks, Matt.